Hi, I know you always try to have a resilient application and you use this one, but did you try to test your resiliency? I don't think so. So we are here in this video to do that. We will introduce a new tools with this name and use it in a simple test project to show how we can test our resiliency and inject some chows in our application. So let's go. Jumping to the code, let me to talk a little about chows and start from this question that what is chows? The first one is failure. Chows usually start with something going wrong. Maybe a server crashes, an API stops responding, or an AI agent makes a bad call. By themselves, these problems are often small and easy to fix. The real issue starts when the failure is spread to other parts of the system. One small problem can trigger more problems, creating a chain of reaction that affect things far beyond where it started. And in this form, we will have many problems. The second one is uncertainty. In Chow's situation, you rarely have all the information you need. Data might be missing, delayed, or, for example, simply wrong. Teams still have to make decisions, even when they don't fully understand what's happening. This uncertainty makes it harder to know what's causing the problem and what might happen next. The less visibility you have, the more unpredictable everything becomes. The third one is complexity. Modern systems are made of many connected services and tools or dependencies. Each part might work perfectly on its own. When they interconnect, unexpected things can be happen. As systems grow, it becomes almost impossible to understand every connection and predict how a small change or failure will impact everything else. And the last one is emergent behavior. Sometimes simple actions combine in ways nobody expected. A small event can set off a chain of reactions that lead to surprising or even disruptive results. No single component is directly responsible. Instead, these outcomes come from the way different parts of the system interact with each other. That's what makes emergent behavior one of the hardest parts of the chaos to predict and manage. Usually, we have one mistake, and that is understanding the difference between resiliency and stability. Stability means keeping things the same, but resiliency means being able to handle change and keep moving forward. A stable system tries to avoid disruption, but a resilient system assumes disruption will happen and is built to adapt and recover and keep working. In a world full of uncertainty and complexity, resilience is more important than stability because change is unavoidable. But usually, engineers and developers just pay attention to stability and forget the resiliency. The goal isn't to avoid chaos. The goal is to learn from it, adapt to it, and come out stronger on other side. And in this slide, we have some implementation. We will use it in our code. So instead of waste our times in this slide, it's better to jump to our test project and describe each part of the code in there and understand in the semi-real scenario. So let's go. Okay, in our test project, we have two services and project as a microservice, and in one of them we have order API, which calls the payment API. So let me jump to the order API to see what we have in there. First of all, we have program.cs, and in there we add the payment client service, and whenever we need payment client, we will return client with this base address. And also we use poly to define some policies in there. For example, we define the retry policy, circuit break policy, and timeout policy. And all of them defined in the another class with name of infrastructure. In infrastructure, we have these policies. For example, in timeout policy, we will guard the responses for 2 seconds for the timeout, and then we will increment the time count, and this time count will be used in the front end. Also, we will write something in the console, and that will be finished. And for the retry policy, we say if we get the transient HTTP error, like for example 500 series, or we get the timeout rejected exception, or the status code is not found, we will retry the action. And in there, we will retry for 3 times, and the interval for each time will be increment by this math.pow. It means that for the first time, we will wait for 2 seconds. For the second one, we should wait for 4 seconds, and the third one will be waited for 8 seconds. And in each retry, we will write something in the console. And for circuit breaker policy, also again, we have to handle transient HTTP errors like 500 series and timeout exception. And in there, we will take here for the 3 times, and the interval of these 3 times is 5 seconds. We will do these things. First, we will break that, and after some seconds, we will test it on the half open, and if it is confirmed is open, we can allow the requests comes again. And in the rest of the program.cs, we have some endpoints. One of them is for rendering the UI, that we will see that in infrastructure class, and is a very simple HTML code. And we have health endpoint to get the health of the service, and also we have order, which is the most important one in the endpoints. In there, we create some random things for order ID and amount, which comes from the HTML, and then we try to send the request to process payment. In here, in the order API, you saw that we injected some resiliency with poly. But in payment service, we will inject some chose policies with the CME. So it's better to jump to payment client. But before that, you can see in here, we handle multiple exception in there. So let me go to the payment client, and in there, we can see some endpoints for health and pay. But in pay, you can see we have Chaos Manager. In Chaos Manager, we should inject some Chaos policies, and then we can run the action in these Chaos policies. So if we jump to the manager, you can see that we check it that it's not on the production, because we will do that for test or a stage environment. And in executed with Chaos method, we will define the policies in there. We use monkey policy that comes from the CME library, and in there we injected exception, and when this action will be executed, the monkey policy will injected in exception in that. And also we need some latency too, and we injected some latency from the setting, and because we want to have both policies, we can wrap them to one policy. And in here, we wrap them to Chow's policy, and Chow's policy is ready to call the action. So in here, this action will be done with Chaos Manager. And in other endpoints, just be will to enable and disable the Chaos and get the status of that. It's very simple, and we can just run it and see the result. And also I have one Docker Compose file to run both of them with each other. Let me open new console and go to folder of the project, and in there, make the Docker Compose up. Okay, it's ready to see the result. I open it in localhost 5000 port, and in there, if I refresh to be sure it is the latest version, and in here I want to toggle Chaos to disable. As you can see in here, it is disabled, and also in the events timeline, you can see the log. And if I send the request and order, you can see everything works fine, and the request went to order service and then pass it to the payment and come back to order successfully. But if I try to make this on, and enable, in here also is enable, and send the order, you can see something is not correct, and some exception and delay injected to the request, and it takes much more time for processing. In here, you can see the circuit breaker was in half open and now is in open. The retry one is 4 because one for successful one and 3 for in here, and timeout is 5. If I reset it and in toggle enable retry it, you can see the better. Okay, now the circuit breaker is open and I want to reset it and make the semi enable and send the request. You can see the circuit breaker gets open, and in here we have 3 retry and 4 timeout. One timeout is for first time and a retry for 3 times. So totally 4 times we have a timeout. And you could see that semi could to inject some exceptions, some delays, and we could test our resiliency in the best form. Of course, this is very simple example just for demonstrating the concepts. For more information and for understanding better Chow's engineering, you can read these books and also you can search about it in many projects and repositories. Just we would to introduce this one to use it and search it about it in your projects. That's it. Have a nice day. Bye bye.